I'm going to talk a little bit about myself because I come with a sort of cross-domain and cross-industry experience, having applied AI to different business problems. Introduce my company that I work for, and give you a sort of point of view on AI and what we have seen in the industry and what can be really applied in the space of media. And maybe go through some of these which kind of interest me in media space as well. So first thing I must tell you, I'm not a media expert. So this talk is going to be more from a machine learning practitioner kind of standpoint. And I'll also kind of try to see what could be the future in terms of those exciting developments in media space. About me. I think in the introduction, 1997, so I started with a very technical background, doing my research in the area of time series analysis. So like the first slide said, unwittingly ended up creating an algorithm which I didn't realize the value for until much later, when the paper was actually published. LSTM paper was published in 1997. That's the year I finished my master's degree. And after post-graduation, I spent a few years in General Electric, a lot of work on our devices, SCADA systems, and working in areas like turbine controls, power management, these sort of systems. And spent about 6 years in telecom industry. Like the picture shows, nothing to do with cell towers and all of that sort of stuff, but mostly with business applications in telecom, like customer relationship management and billing systems and so on and so forth. And of course, the analytics side of telecom as well. Worked for Canadian government 2011 to 2013. Did a lot of work on modeling. Modeling from the perspective of developing these models for risk models for commercial carriers. And this was for the Ministry of Transport in Canada. And 2013 to 18, did a startup in the higher education space. And that company now has got acquired, and it's part of NStarX now. And so since 2018, have been into consulting. And we do a lot of consulting work for different industries. Some of these you have seen in the first slide: financial industry, telecom, healthcare, and high tech, and so on and so forth. So that's a little bit about myself. Introducing NStarX, we are a product engineering company. And what we essentially do in kind of simple language, we build products for our customers. And these products are data products and end-to-end products, which involve building engineering platforms for large customers and enterprises. So we build these very complex pipeline work, which involves a lot of aspects which are very critical to AI today, including data processing, data management, experiment management. How do you run your machine learning experiments? What sort of models would actually fit? So there's a lot of core data science work as well as core engineering work as well. And of late, we have ventured a lot into model management and how do you do model inferencing? How do you set up all your models in production? And most importantly, how do you ensure all of the models that are in production are accurate as well? Because once it hits production, you kind of need to continuously monitor your models. And in the process of monitoring, you discover that there is a fair amount of challenge from an engineering standpoint on how you keep these models accurate in production. So that's what we do. And we have worked in multiple domains, again, built AI platforms for healthcare companies, financial companies, and so on and so forth. Now, some of the AI terms that you see in this, I think we have been talking about AI all day. And these are the 4 areas, if you see ML. Now, AI is a term, I think one of the speakers before talked about AI and how it's kind of misleading, the term intelligence, artificial intelligence itself. Actually, machine learning and deep learning is probably a more practical term because intelligence itself is really hard to define. I mean, if I ask you a question, each one of you, how would you define intelligence? It's very likely that I would get a different response, and probably all of them are correct. And when I kind of started thinking about this, even leading researchers into intelligence, cognitive scientists, they don't have an accepted definition of what intelligence actually means. So there's no accepted one universal definition of what an intelligence is. So I think defining artificial intelligence is even harder because we struggle with even defining intelligence. But however, I think some of the earlier speakers that have spoken, AI really has a kind of a history. Sort of, when I think of AI, I think of an AGI, artificial general intelligence, and definitely we are nowhere close to what an AGI actually means. And that's the current situation. But machine learning has a lot of practical applications, practical uses, and as a company and myself, I'm really driven by how can you solve practical problems in an enterprise using machine learning. And so my perspective is going to be very practical in terms of how do you deal with this? How do you deal with data? What kind of value can you derive from it? And most importantly, how do you build a business case around the sort of investments that are needed to stand up AI platforms and implement use cases in the industry? So a lot of focus has been around that. Now, a lot of the reasons that you see to your right, enhancing efficiency, reduce OpEx, enhancing viewer satisfaction, are fundamentally some of the reasons why we apply AI. And for us, it's very important when you embark on a machine learning project. We first look at all of the data sources from a practitioner standpoint. And there's a lot of toil in terms of data management. I think it's often overlooked because if you see an entire machine learning process and life cycle, 80% of your toil is really handling data. And data is messy. Data is messy, and I think we've discussed some of this in today's panel discussion as well. So you have different databases, different legacy systems, and the data is not all clean, so you have to curate the data. You have to create some sort of a data store out of which you could start building these models. So there's a lot of toil that is involved in data processing and data management. But more importantly, before you embark on a machine learning initiative, it's very important to figure out what the success factors are. How do you measure the success of the project? So it eventually has to tie to one of these numbers. What is the efficiency improvement you get on account of this? Am I reducing the OpEx, and by how much? So I think those success factors are very important before you start these projects. So as you go through so if I take a 9-month project, I'm just giving you an example, you'd spend about 60 to 70% of your time just dealing with data. So if you do a great job at data processing, your data wrangling, and then you're able to catalog some of what you find in your data, you're able to build what I would call the catalog, and I'll come to catalog in a little bit. This is something which is very popular in other industries as well, but I think it has an applicability to the media space as well. So once you get all of the data in, then you go through a sort of iterative machine learning lifecycle where you have a bunch of data scientists who are building these models, iterating in these models, and seeing what is possibly the best sort of set of results that you can get from your data. And then once you do that, then there's another problem that you got to handle is what we call the operationalization of machine learning. So once you have built some of these models, experimental models, they need to be tested, they need to be validated against independent data sets. So you go through a sort of a testing phase as well. And there are industries in which you also are worried about regulatory constraints. So you need to ensure that you're taking care of all the regulatory side of it, and also things like data privacy and security that we discussed in the panel again. And that's very important today. Now, I think my next point is really kind of as a continuation of what we discussed in the panel. See, AI architectures today are also sort of evolving. See, the thought process, traditional thought process was, hey, let's get all the data wherever we find it that we think has value. Let's create first a warehouse or a data store. And then once you build the store, which itself is like a big project in itself, and then you have all of these data scientists and data engineers, they come in and they work with the data. That kind of pretty long-tailed project. But I think one of the things that's been evolving, and that's something in a company we have been looking at some of these recent architectures is really a distributed pattern. So instead of, let's think about it this way, right? If you are centralizing all your data, and then you're getting all your data scientists to work on it, then what you're essentially doing is you're shifting the data and getting it closer to the algorithms that work on the data. So the pattern of distributed machine learning is exactly the opposite. You kind of push the algorithms actually close to where the data is. So let's say you have data in different zones, and typically one good example would be huge enterprises that have offices across the world. And then every country, let's say you have offices in 5 countries, and you have data stores in every one of those countries. Now, because of data residency issues, data actually can't move. So data, you can move the data, but still you want to derive insights from the data. And your models, you want to learn all of the patterns across in all of your distributed zones. Now, how you enable this this was a concept which was introduced by Google a few years back. It's called federated learning, or federated or distributed machine learning. So essentially, your AI platform is no longer a centralized platform where data resides and then you get your algorithms to work on your data, but now it's all of it is kind of pushed to the edge. Pushed to the edge, or every node or zone, you can call it what you want, but you have these algorithms which are, as the algorithms work on data, there's a second kind of communication that's happening. All of these models are sharing their insights with each other. So which means, without actually moving the data from one zone, you're able to understand the patterns in another zone, and then you're able to build one model which has learned from all of the data. So that's one way of getting around this problem of not having to centralize data. And second big advantage is from the perspective of data security and privacy. Then you build these tightly controlled zones where data actually can move out, but all that moves is basically network information or deep learning network information, which you can actually allow to move because it's not governed by data security or data residency. So I think these are the sort of architectures in AI that are evolving. And to give you an example, we have an interesting work that we are doing for a company in the space of digital identity. So digital identity is a big thing now. How do you verify the digital identity? Because so many of your transactions or business transactions are now online. And so verifying the identity of a user, it's extremely important. So for this company, they have like 5 or 6 offices, data centers in different zones. So they're facing an issue because they're not able to scale fast enough. They wanted to expand. They had data centers in US, they had data centers in Europe. They wanted to expand to other regions geographically. So how to enable that? We got there some of the infrastructure on the cloud, and then we built all these distributed zones. So all of the data that is collected from every geography, you had algorithms which were working on the edge, which were gathering patterns, which were gathering insights from the edge, but then we are able to harmonize all of those so that now when we have a global model, it has learned from any identity-related fraud in any of the zones without the data actually moving. So these are some of the more recent and, I would say, state-of-the-art machine learning architectures that are evolving, which I'm sure actually in media space it has a huge implication as well.
Thank you for this talk. I have a question about data residency and sovereignty and the implications of getting insights and aggregating them. Is there a risk that some of those insights will lead to exposure of the, the identifiable information?
Yeah, that's a great question.
Thank you.
So typically, the pattern of distributed learning, what it ensures is we put guardrails in place where what actually moves from one zone to other zone are really sort of think of it like if you have a deep learning network. So if you work with deep learning, essentially the knowledge of all of the patterns is actually captured in sort of a distributed network, or sort of think of it like a deep learning network. I mean, in technical terms, these are called just weights and gradients of a network. So you can't connect that information in any way to any PII sort of information in that specific data residency zone. So the messages that move are literally just only the network parameters, which have nothing to do with the actual source data. So when you build this model, there's an exchange of all of these different gradients from different deep learning networks that are working in these distributed zones. That ensures that the information that is being passed is also actually in the process when the data is in motion, even that is encrypted. So it's practically, I would say, impossible for you to take that information, even if you manage to intercept it, to reconnect it to some sort of a PI information or anything that we can connect you potentially to a customer.
Thank you for this answer.
Yes.
You mentioned regulatory requirements, but during the panel is mentioned that governments are scrambling to figure out what regulatory requirements are. Yeah. What do they look like right now in the space?
Oh, they are getting, I don't know whether you'd call it worse or better, but they're getting worse by the day. because people are, if you're in Europe, it's like GDPR is what drives everything. You're in the US, it's FedRAMP. And what customers are asking us today is, okay, let's say you built a zone and you claim that you're GDPR compliant, for instance. Then you have to have a way of demonstrating that it's GDPR compliant. So we build what is called sort of the trust, sort of a trust layer, where all the claims that you make can actually be verified through the trust layer. I think that's the approach we are taking, and response to your question, every day it's getting harder.
Good luck.
So I want to hit on a few use cases which I find fascinating, because I'll try to take a sort of a data science point of view on some of these. And some of these processes where I think we can kind of look at some of the learnings from across other industries as well. Optimal timing for viewership and kind of resource usage. I think the best example would be Netflix, and few more like Netflix as well. So what they really do is, in this, from a data science standpoint, and of course there's a data collection phase like every machine learning project. And in the data collection phase, you generally collect two kinds of data. One is demographic data, of course, location, age, and device type, and all of that sort of information. Second is more of a user sort of interaction information or engagement information, where what kind of content do you watch, when do you watch it, how frequently do you watch it, and what are the pauses, and all of that sort of engagement dynamic information. And Netflix had something like an algorithm which they used in the past called collaborative filtering, and which they use that for basically recommending to you what sort of content which might interest you. So it's all based on collaborative filtering. I'm sure collaborative filtering has evolved over the past few years, and I'm sure it's become more sophisticated now, although Netflix probably wouldn't tell you exactly what their latest algorithm is. But this is something that where from a data science standpoint, it is an interesting problem to solve, because for you to predict an optimal timing for viewership of a certain content, you need to also do some sort of segmentation of your audience as well. So based on some of the signals that you collect, can I segment my audience? And then based on that segmentation, can I come up with an optimal time for when do you think this specific thing should be available for viewing to a certain customer. So I think it's very interesting from a data science standpoint, because there's a lot of core machine learning work that's behind optimal timing for viewership and resource usage. And there are it's just not Netflix alone, but there are other companies as well which do this sort of thing now. Second is a content management process, right? Now, if you see the content management process in sort of different phases, right? Acquisition, and we talked a lot about metadata, right, in the panel as well. Metadata certainly is an exciting area for us, because metadata is something even in other industries. I will talk to you a little bit about how we deal with metadata and maybe some of those best practices there. Then things like indexing, then be able to actually search. Again, we hit on that point. How do you make all of this searchable and you can access it very easily? Now, acquisition of data is, again, there is a ML side of it as well, because of the variety of content, the size of the content, complexity of the content. There are a lot of efforts around how do you reduce the toil and pain in this process. Traditionally, you would, again, have people, data engineers or business analysts, sit through all the data and try to acquire all of the different data that you need. But today, there are machine learning tools that are coming up, which will kind of reduce your pain in that area as well. So which kind of, it's like saying, okay, you have different sort of structured and unstructured data, but is there a way I can have a ML algorithm, even at that stage? Can I analyze the source and then come up with saying, hey, look, these are all the different data sources, be able to catalog it, and then be able to tell you what is clean, what is not clean. And there are sophisticated algorithms in place today which can even clean the data to a certain extent. So I think there's a lot of work that is going on in just in the space of when you acquire data, how do you ensure it's clean, how do you ensure it's curated, and how do you use machine learning in the entire curation process as well. Second one is metadata generation, which is like, of course, all of us realize the value of metadata. And in the industry too, we have seen that one component called catalog. So this is something which is very popular in other industries. What we do is we build what is called catalog. In your case, it would be a content catalog. So once you're able to build this discovery layer, how do you catalog your content in such a manner that it's accessible to most users, makes it searchable, and you create a structure, sort of a data model in your catalog where you're able to store all of the meta information in terms of your metadata for all of your source data, and how do you create an entire catalog experience out of it. So you can go to a catalog, you can look for content that you need, you can do all kinds of searches on it. And this sort of a catalog has manifested itself in different forms, like product catalogs, content catalogs, and even AI itself has a catalog now. One of the popular things in components in AI today is what you call the AI catalog itself. See, because AI process itself is so complex, right from your data processing all the way to operationalizing of your machine learning models, you generate a lot of telemetry and information through the entire process. Sort of pipelines that you use, what kind of pipelines do you build, and experimentation is a highly iterative process. So if there are a bunch of data scientists who are working on a specific problem, you throw a problem at them, then all of them would potentially take different approaches to it. They would generate different experiments with different sort of results. There are some experiments that work, others don't work. But then how do you have a way of managing your entire process so that in a catalog, somebody can go to that catalog and say, hey, look, this is what my machine learning process looks like today. I have all of these different things that are happening. There are scientists who are building models. There are some scientists who are building some explainability layer. How do I know the current state of the entire process? You actually catalog all of that as well. So there's this very popular notion of an AI catalog that's in existence today, and what we have found, it's kind of very invaluable to have AI catalog in any sort of enterprise AI implementation. So that's something that I think could have huge value in the media space as well. And then, of course, the final, in terms of retrieval, I think retrieval, we could potentially, LLMs to have huge value in that. Now, in terms of interactivity with the catalog, the traditional catalogs used to be more kind of menu-driven. You go, you click on it, you have some filters in place for you to search stuff. But today, if you integrate LLMs, the process of retrieval could be, you can take it to the next level. Like, and you can ask questions in natural language, get to exactly what you need. So that there's a sort of LLM you can integrate to a process of a catalog as well. I think the third point on reducing errors and enhancing efficiencies, I think AI can potentially detect and correct issues in things like live broadcasts as well. I think that's a very interesting area for me. For example, there is this company called WitChecker. I think you see this icon out there. For example, things like audio-video sync issues, these sort of issues can be corrected. Not that I'm promoting WitChecker, but just an example. I'm sure there are a lot of other tools like this as well. I'm going to just focus on challenges and considerations and sort of talk about where I think some of the AI potential use cases and how AI will sort of disrupt media. I think one of the things what I observed just in terms of numbers, I think this is latest analyst figures. This market is almost going to be like 100 billion in the next 5-6 years' time. So it's a 100 billion market with a healthy kind of CAGR. One of the challenges that you're likely to face is really upskilling your workforce. Because AI is moving so fast, now you're getting to a point where you have a lot of these models that are working together with the introduction of LLM. A lot of these new roles, I think you need to really start upskilling and thinking about all of those, whether these are system engineers, data engineers, and I think there was sort of a new role also called prompt engineers. I see a lot of job requirements of prompt engineers as well. I think these sort of requirements, you need to start thinking about how you upskill your workforce to deal with it, because in your broadcast workflow, there are so many scenarios where you can apply AI at every point. You really need an enterprise-grade platform for managing all of these, which means a lot of these new roles, you have to start thinking about some of those. And I think what is also important from our experience, what we have done is we have set up a sort of an AI lab in partnership with one of our partners. And that's a lab which allows you to do rapid experimentation where we give you the entire infrastructure, AI infrastructure plus your software layer, including hardware, OS, software, and the tooling that is necessary for experimentation in AI. And where you can come in, you can bring your data, And you can do rapid experimentation and build prototypes in literally about 2 weeks, 4 weeks, and 6 weeks. High amount of acceleration in trying out your AI experiments with minimum investment. I think those sort of AI innovation labs are going to be pretty important in media space as well, where you have to make this sort of investment. Either you do it yourself or you have somebody build this sort of lab experience for you. I think some of those, what I see in the future, one thing is personalized content delivery. I think a lot of it in the previous speaker talked about some of the personalized content delivery. I think that is going to accelerate, get more and more personalized. And we'll also see more automation. This naturally will lead to more automation in your entire production process, of course, with increase in efficiency and reduced OpEx and so on and so forth. And advanced audience analytics. How do you create better segmentation in terms of your audience so that you can deliver more personalized services to them? That's going to be another area. And of course, with the advent of the era of LLM, content generation, of course. I think I've seen some interesting tools which can kind of, based on an idea, I think we discussed about some of these ideas in the panel as well, where you can sort of generate content, video content, rich video content, which looks kind of real lifelike, and you can generate it through just text. So it's basically converting your ideas in terms of text, creating sort of video imagery out of that. And it's getting more and more realistic, as you see. And you've heard about deepfakes. All of you have heard of deepfakes. I think that was really the starting point where it wasn't called generative AI during those days. They were more like generative adversarial networks. And they created these images or pictures which kind of looked like a real person, although it wasn't a real person. Although it created a different set of problems, this entire area of deepfakes. But I think enhanced content generation is definitely going to be one of those areas where you're likely to see a lot of AI happening in this space. And I think interactive and immersive experience as well in terms of that. I think experiences are going to become more immersive. We are already seeing augmented reality in the live broadcast shows. I think you'll also start seeing where it will get, you can have a sort of very immersive experience through that. And more importantly, maybe at the next stage, you're also seeing interactive experiences. Like things like in the sort of sports coverage. I think the previous speaker, he had some very cool videos on the sports. I think I do see a situation where viewers can interact with content in real time, where camera angles and what kind of angles you want to watch, I think it can get more interactive. And another area is really optimized content distribution as well, like dynamic ad insertion that many companies are doing now. And finally, I think I'm going to end this with saying ethical AI. I think ethics is a very important area of AI. And there's a lot of research happening in that domain as well, because it's a very complex topic. But I expect to see a lot of these frameworks which are adapted to a specific industry emerge in terms of ethical AI frameworks. So it's an exciting area to be in, and particularly in the era of generative AI, I see a kind of natural fit with media space. And a lot of this cross-learning from other industries, I think media industry can use in terms of building this sort of AI layers and AI platforms to drive all these efficiencies in your broadcast workflows. So I'm going to stop with that, and thank you for, any questions?